Welcome back. Today we'll explore some of the most important security concepts. What's the difference between encoding, encryption, hashing, why does it matter, and what's used in the industry today? Then we'll go back to coding, where we are going to store our users in a MySQL database and use them to log into our application. So let's explore now some terms we keep encountering in the realm of security. When encoded, data is just converted into a different format using a public schema. It's a reversible function which does not add security value. Its purpose is not to protect data, but to ensure data is safely and consistently transmitted or stored. Examples are character encoding like UTF-8, base64, which by the way increases the data size by 33%. The Spring Security Codec folder contains some of the classes for encoding. We can use encoding to store data in database, transmit authentication tokens, or prepare data for JSON or XML serialization. If data is not properly encoded, emoticon, for example, can break parsing, or special characters can cause SQL vulnerabilities. Encrypted data is unreadable unless you have the encryption key. Can be applied to data at rest and in transit. We have mainly three types of encryption: symmetric, asymmetric, and hybrid approach. In the symmetric type, the same key is used both for the encryption phase and decryption phase. The most widely used symmetric encryption algorithm is AES, Advanced Encryption Standard. It's the one Spring Security uses as default. The second type is asymmetric. Public key is used for encryption and private key for decryption. The most used algorithm is RSA. The keys are mathematically related, and it's almost impossible to figure out the private key from the public key. The cost of performance, though, for large files is quite high. A hybrid approach of RSA for secure key exchange plus AES is used most of the time. Alice generates a EAS key, Bob a RSA pair. Alice encrypts her message with AES, which is fast, and the AES key is encrypted with Bob public key. That's slower for large data, but it's okay for small keys like the AES key. Bob will then use his RSA private key to decrypt the AES key and then decrypt the AES ciphertext, our message. Spring Security gives some encryption tools like encryptors for key management, which we'll talk about in the following video. Hashing is a one-way function. It's not encryption because it's irreversible. We do not have a decryption step. We have an input, we can get a fixed size string of characters, can be called hash, digest, or fingerprint. It's deterministic and generates an avalanche effect. A small input causes the string to change completely. It's used for password storage, so the password can be protected if database is compromised, or used for create unique identifiers, all the cases where there is no need to store the original value. It can be salted, meaning a random value salt is added to the input before hashing to make the output unique, even if the two inputs are the same. Famous hashing algorithms in Spring Security are bcrypt, scrypt, argon2, which we'll explore in the next video. Let's update the POM and the property file with all the database connection information that Spring needs to know. We can remove the H2 dependencies and add the MySQL connector in our POM. And let's put the data source URL and driver, your MySQL administrator username and password, in the properties file. Just running the application, we should now see two users in our happy users table, all filled in with our data we had previously in the initUser method. So let's say we want that those users are the only ones that can access our application. The place where Spring Security looks for users is the loadUserByUsername method, which will return a UserDetailsService object. I'll remove the previous content and first add the data source object as injected parameter. This will establish a connection to the database We can then create a JDBC User Details Manager, which is a subclass of UserDetailsService and an implementation of a User Details Manager that let us not only read but also create, update, and delete our users in the database. The manager will automatically look for a user and authority tables, but since we want to use happy tables and happy users, we need to instruct the manager to use our tables instead by writing queries. And that's the important part. Now we should think backwards and fix the rest of the code. First, we need an authority entity where we keep track of a list of authorities per user. And we create a simple repository for the authority entity we just created. Now we have users and we have authorities. We need a way to express the relation between the two, something like a happy user authorities table. We can create this new table just by adding a many-to-many relationship between our users and their authorities in the user entity object. Our domain user will have just one authority for simplicity. Let's update our init method by adding the authorities entities to the database and the authorities to the user's authority property. As last step, we'll finally implement the password encoder by specifying the two main methods, encode and matches. We do not encode anything for now, so let's then return the password in plain text. So we can see that now we have three brand new tables, one that contains users, authorities, and the happy users authorities. We can try now to log in the browser with our user gcallpanda and bamboo password. We say that we can easily access our endpoint only with our database stored users. We successfully connected our Spring Boot application to a MySQL database. Use a JDBC User Details Manager to tell Spring Security to give access only to our own users. We also broke down some essential concepts: encoding, encryption, and hashing. That's a big step forward, and you should really feel proud on how far you've come. Thank you for watching. Don't forget to like, subscribe, and I'll see you in the next video.